This is a tutorial on doing linear regression in SPSS. The dataset we're going to use as an example is the smoking and cancer dataset. We can see here that the first column has occupation category, the second column has smoking rate, and the third column has cancer rate. Regression usually follows on after correlation. So once you have discovered that two variables are correlated, the aim is to find an equation connecting them and then predict a value for the dependent variable given a value for the independent variable. So in this example, we may want to predict the cancer rate if we're given a value for the smoking rate. We obtain a scatter diagram of the data by selecting Graphs, Chart Builder, Scatter, and dragging smoking to the x-axis and cancer to the y-axis. Then when we click OK, the graph will appear on our output file. To edit the chart, double click on it, and then to add the equation of the regression line, you right click on one of the points and then select Add Fit Line at Total. So what this tells us is we can obtain a value of y by sticking x into this equation. SPSS has found the best line through these points. So in this example we can say that y equals 3 plus 1.03 times x. This asterisk sign represents multiplies by. Or, to put it into this context, cancer rate equals 3 plus 1.03 multiplied by smoking rate. So, for example, if the smoking rate is 85, then we can predict the cancer rate by doing 3 plus 1.03 multiplied by 85. We can use the calculator on screen. You can obtain that from the accessories menu. Three plus 1.03 multiplied by 85. This means that on average, people with a smoking rate of 85 will have a cancer rate of 90.55. Going back to this equation here, we can actually interpret what these values mean. So, we've said that smoking equals, no we haven't, we've said that cancer equals smoking times by 1.03 plus 3. This 1.03 tells us that if the smoking rate increases by 1, the cancer rate will increase by 1.03. Okay? And this 3 tells us if the smoking rate was 0, the cancer rate would be 3. At the top right of the scatter graph, we are told that r squared equals 0.462. This is interpreted as the smoking rate explains 46% of the variability in the cancer rate. In other words, smoking is not the only factor here. There are other factors that could explain the remaining 54%. If you want to define out what those other factors are, you'd have to move into something called multiple linear regression, which will be covered elsewhere.